Hi everyone, this is Roshov Roy, and this video demonstration on Spark is a part of the Big Data Analytics lab at NIT Kutukshetra. So in this video, we'll be addressing the problem of how to run our Spark scripts from the command line instead of having to copy paste our code line by line into the Spark shell. Although the method of copy pasting each line is useful for debugging purposes, but it is not suitable for learning larger Scala files or Python files in Spark. So here I have started up Visual Studio Code, which has an integrated command line terminal, and here are my Spark programs. So if we see this current Spark program, which calculates the average of the student scores, so we can see the student data. Here Rishabh has 50, Amit 62, and then Rishabh again has 50, 45. So in this student average Scala file, we will read the data and split the data into two parts. The second one is the score, so we typecast it to integer, and then we can print this art, convert it to the RDD and print each line. Now in our current command line, we have started up this command line in the folder in which this Spark program resides, in which the Scala program resides. So first we start up our Spark shell. So now we can see that our Spark shell has started, and by default it is using a Scala. So earlier what we were doing is we were copy pasting each line into the Spark shell. So now we can control V here, and Scala will read this, parse this code, and then we can see that this is the output of the data read by the Scala program, and then we can copy paste again the other lines into the Scala shell, and Scala will process it line by line to finally give us the output of the student average scores. But this seems to be too cumbersome for larger programs. So what we can do here is we can use this Scala command known as :load, and then you give the data path, the path to your program. So here I type student average dot Scala and then press enter. So Scala shell automatically loads the entire student average Scala file and gives us the output at once. We can see another program such as the common word counting program. So here we are loading the data from the words.txt file, which has multiple similar words, and we want to get the frequency of each unique word. So first we create a map, and then we map each word with a frequency of 1, and then perform the reducing step, and finally the collection step, in which we compile the output of the reduce step. So here again what we can do is type :load and give the path to our program word count.scala, and we can see here that Scala is automatically loading this program, and then we can see the result that we have this array in which the frequency of the word dog is 1, hello is 2, better is 1, cat is 2. Here we cannot see the output of the reduce step in parts. It may happen that the output is produced in 2 or 3 nodes, but this collection step compiles it into one single array. Again we have the k-means program. So here is the k-means data, in which we have a 3-dimensional data. So 0 denotes the index of the data. This is the first data first feature, the second feature, and the third feature. So here we read it in the libsvm format, and then set our k-means cluster size to 2, and finally we evaluate the clusters and print the clusters. So again, what we can do is load k-means dot scalar. So here we can see that the distance measured is the Euclidean distance, and the model score is 0.99, and these are the two cluster centers. So now if you want to quit the Spark shell, so similarly we can do :quit, and then we have successfully quitted from the Spark shell. And now similarly, if we have a word counting program written in Python which uses the same Spark libraries to perform map, reduce, and collect. So here we can see the program that it reads the same word file, and then we convert it into a word map. Here we use a lambda function, which is an anonymous function, to first split the line by space and then convert them into tuples of the word and the frequency 1, and then we reduce by the key, which in this case the key will be each word, and then the frequency will get added as a plus b. And finally we do not use the collect step, so here you will be able to see that the output is coming in parts. Then we finally save this as a text file in a word count output folder. So now to run Python programs, what we can do, we can submit this job to spark-submit and then give the name of our Python file, spark submit sparkword.py. So this will submit the Python job and it will resolve all the dependencies required. And finally we can see the output that has been produced. So here you can see this is the current directory. So these are my programs, and here a folder has been created, word count output, which was the same that we had specified here. And here you can see that this is the part 0 of the output, in which we have 2 words, and then this is the part 1 of the output. So this is the output of the reduce step, which is produced in 2 parts. So in this video we have just learned methods to run our entire Scala program at once, or our Python programs in Spark. So the first command will be :load and then type the file name, and the other one for to run Python files is to use spark submit and the file name. Thank you.